Hi everybody, this is Lesson 10, Understanding Multiplication of Integers. Our essential question is, how can we use examples from the integer game to show repeated addition or, that is multiplication. Okay, so we're going to use the example of the integer game here. Of course, you always pause it and write it down. Make sure you're listening to what I'm saying as well. Okay, part A. We want to use the integer game as an example to show repeated addition or multiplication. In example 1, part A, I'm going to give you 4 random cards. So let's go ahead and write in these numbers. The first card we picked up was 3. The next card, -1. The third card is 10. And the fourth card is -5. So we're used to figuring out our score on the number line, and we're saying, okay, here's my 4 cards. Let me go back and forth. Do I go right? Do I go left? So that's for addition. And then, of course, subtraction problems, we change to become addition. So for this, though, we're going to imagine that our -5 card, we're going to imagine that our -5 card gets repeated. So see these stars here? Where you see these stars, we're actually going to put the -5 in for those as well. So we're showing that this one card gets repeated 3 times. Okay, let's write a product. Do you remember what product means? Answer to a multiplication problem. Okay, so we're going to write a product that describes the 3 matching cards. That's these 3 right here. So how would you show a product or multiplication problem with those? Okay, there are 3 of them, and they're -5 each. So, when you were in, first or second grade or third grade, you've pictured, 3 groups of 4 apples, something like that. So this is saying 3 groups of -5. So we can write it exactly like that. 3 times -5. In this case, there is nothing in between the 3 and the -5, so that means multiply. Okay, you're going to think of that as times. You're going to see that a lot from here on out. So if you don't see a sign in between 2 numbers, it means to multiply. Now we're going to write an expression that shows how the star card would change our score. So if we did have to have that one 3 times, how would that change our score? All it means is on the number line, you would go 5 to the left, and then you would go another 5 to the left, and then you would go another 5 to the left. So if you notice here, there is something in between the parentheses, the addition sign. So that is not multiplication. You see that there is something in between them. Okay, so we would be going how many to the left? That one is going to go right here, the final answer. So write an integer that represents the total change. So how did our score change? If you go to the left 5 times, and then another 5 times, and then another 5 times, what's your overall change? You went to the left 15 units, so -15. Okay, and all this, this one that we skipped, all this is saying is that 3 times -5 is equal to -5 plus -5 plus -5, just like you learned with multiplication in the past. Okay, and then the quick equation down here is that 3 times -5 will change my score by -15. -15. Okay, not too bad. We're going to go on to the next page, and we're going to do a new example. So for part C, here's your scorecards. Whoops. Sorry about that. Okay, for part C, let's go ahead and put in -1, 5, -3, and 4. Now, if you notice, this time the 4 landed in the star card. So if you copy these, let's pretend that the 4 card got repeated. Oh, that got repeated more than the last time. So the product that would describe the 5 matching cards, here's the 5 matching cards. The product here would be 5 times 4. 5 times 4. Which is the same as what we have here, 4 repeated over and over. So that would be like saying 4 plus 4 plus 4 plus 4 plus 4. And then the next line, this might seem repetitive to you, so this will go quick. It's just saying that 5 times 4 is equal to 4 added up 5 times. 4 plus 4 plus 4 plus 4 plus 4. Okay, so now the real answer, the real thing that we're looking for is what does that equal? So what do those 4s equal? All those 4s equal 20. And that's because 5 times 4 is equal to 20. Okay, so that one actually seemed a little easier. I think probably because they were both positive. So using the expression 5 times 4, relate the multiplication of a positive valued card to addition. Relate the multiplication of a positive valued card to addition. So how does that work with addition? Well, if we're going to multiply, I'm going to go ahead and type this one. The questioning on the left can be kind of confusing, but let's see if we can understand the sentence I'm about to write. Multiplying a positive number by a positive number increases our score. So in this case, our score went up 20. Let's go ahead and put that in parentheses. In 5 times 4, our score went up 20. And I'll fix that so it all fits on that line. So that's what we're talking about when we say increase. Okay? How about the other example? How about in 3 times negative 5? Well, in that case, when we multiplying a negative number by a positive number will decrease our score. Okay, so let's go ahead and underline those words increase and decrease. Because in this one, 3 times negative 5 equals negative 15. And just in case you were wondering about this multiplication sign or the parentheses, those say the same thing. They both say 3 times negative 5. Okay, hopefully it's not too bad. We're going to look at what happens if I were going to discard some of these cards. So turn to page 65 and let's look at example 2. If all the fours from the playing hand are discarded, okay, so that means I'm getting rid of them, how will the score be affected? Sorry about that. Okay, so if I discard those 3 4s, what's going to happen to my score? Well, I think you all know that that is going to cause your score to go down. So let's take a look at what happens. I'm discarding 3 4s. So that means I'm going down, or I'm getting rid of 3 4s. So let's write that as negative 3 times 4. So instead of picking up a bunch of 4s, I'm getting rid of a bunch of 4s. So if I get rid of those 4s, what will happen to my score? Well, we could actually figure out what it was before and after. So before we discarded, we had 4, 4, 4, 4, and negative 5. So that would be 12, and then we take away the 5, so that would be positive 7. So before, it was positive 7. If I get rid of them, now my score is, well, it's really easy. It's just the negative 5. So my score went down 12. It went down 12. And that makes total sense, because if I'm getting rid of 3 4s, I now have a score of negative 12. Okay, the other question is, instead of getting rid of these 4s, what could I add in? What cards could I add in? So let me kind of show you an example here. What 3 cards could I add in to cancel out or get rid of those 4s? Yes, those would be negative 4s. So I could also pick up 3 negative 4s. So watch this. This is kind of neat. If I pick up 3 negative 4s, that would look like this. I pick up 3 negative 4s, which would also cause my score to go down 12. So if you're noticing, these two problems are actually this, they give us the same answer. So negative 3 times 4 is equal to 3 times negative 4. They both result in a change of negative 12. So in both of those instances, my score went down 12. So getting rid of 3 4s or picking up 3 negative 4s. And that, again, that might be, confusing as far as thinking of the integer game, but if you see it written here, this is the math problem that simplifies it and says negative 3 times 4 is negative 12, and 3 times negative 4 is also negative 12. Okay, the last example we're going to do, these examples are all showing us how we came up with all these integer rules, all these things that we're going to be practicing when it comes to multiplying and actually dividing. So what's really neat is that multiplying and dividing, they're actually, in my opinion and in the opinion of students of the past, it's actually easier than the adding and subtracting. Because if you're noticing, you've got this 3 times 4 is 12, and you've got this other 3 times 4 is 12. Really, it's just figuring out the sign. So the multiplication and division problems will feel pretty simple just figuring out the signs. So like I said, today we're just, going through and saying why this works or how does this work. And the integer game kind of helps us give a visual. Okay, our last example for today is example 3, the product of two negative integers. So in this one, it's saying, what if I discard all the matching cards? If the matching cards are discarded. Well, here's all the matching cards, negative 2, negative 2, negative 2, negative 2. So what we're going to be doing is figuring out what happens to our score when I get rid of all those negative 2's. In order to get that, though, we really got to look at the before score, and then we have to look at the after score. So pause the video, figure out what your score would be. If you picked up these cards in the integer game, figure out what your score would be. Okay, ready, set, go. Okay, if you went 2 to the left, 2 more to the left, 2 more to the left, 3 to the left, 2 more to the left, and finally 1 to the right, you should land at negative 10. Okay, now pause it again, but this time tell me the score if you get rid of all of those. This one should be quicker because now you only have 2 cards left. Okay, did you get negative 2? How did your score change? Look at a number line, either one that you have written down or in your workbook or in that orange paper that I gave you for your dry erase boards. So look at it and tell me, how did your score change? It was negative 10 and now it's negative 2. Did your score go up or down? Be careful. It actually went up or increased by 8, okay? The score increased by 8, okay? From negative 10 to negative 2. Okay, so on the number line, that's going to the right 8 units. Okay, so what were the 4 matching cards? We got rid of the negative 2's. What 4 matching cards could be added? The first thing I want to do is I actually want to show the problem that we did. We got rid of 4 negative 2 cards. So this problem reads negative 4 times negative 2. So negative 4 times negative 2. I got rid of, okay, this is the I got rid of symbol, like the negative. Then I got rid of 4 negative 2 cards. So when I got rid of 4 negative 2 cards, my score actually went up 8. So negative 4 times negative 2 is actually positive 8. The next question says, what cards could I pick up to cancel them out? So now let's imagine what 4 cards, 1, 2, 3, 4. What 4 cards could I pick up to also cancel out or get rid of those negative 2's? And that would be positive 2's. So I could also pick up 4 positive 2 cards, and I would also increase my score by 8, so positive 8. Okay, so hopefully you're starting to see a little pattern here. Seeing how each play affects the score, relate the products that you use to model them. What do you conclude about multiplying integers with the same sign? Go ahead and underline that question there. What can you conclude? So if you notice here, when it says same signs, it means this is a negative times a negative, and this one is a positive times a positive. These two have the same sign because they're both negative. These two have the same sign because they're both positive. So they will both result in a positive answer. So when two numbers, let's say two factors, because that means numbers that are being multiplied. When two factors have the same sign, both positive or both negative, the product, which is the answer to the multiplication problem, the product, let's just say product or answer, will be positive. And then hopefully that kind of gives you a foreshadowing or a hint as to the answer for our final question, which is what can we conclude about multiplying integers in general. So that one, we can kind of draw an arrow. This is when we have two factors that have the same sign. And down here we can say if the two factors have different signs, that means one is positive and one is negative. Then the answer, which is also called a product, will be negative. Okay, so the short version for that is same signs, positive answer, and then different signs, negative answer. And that's for multiplying. So the other thing too, you just have to be careful with this lesson is that you do not forget what we learned in the past when it comes to adding and subtracting. So this is for multiplying, and you know what, it's going to be for dividing too, so I'm not really giving anything away. I want to make sure that we're including everything for this. So for multiplying and dividing problems. Okay, and that's a wrap on lesson 10.